thank you all for coming today. If you haven't signed in yet, the QR code is on the screen, and I will also paste it into the chat once I'm done with my portion of the slides. And yeah, so once again, this is an Arduino technical workshop hosted by AIChE Projects. We are joined today by Gregory Specht, who I will also introduce once more in a little bit. Just before we move on, this event is going to be recorded. By staying in this call, you are consenting to being recorded, especially if you unmute or have your camera on. So please just be aware of everything that's happening. As always, with the start of all of our events, we would like to do a land acknowledgement. So the UC San Diego community holds great respect for the land and the original people of the area where our campus is located. The university was built on the unceded territory of the Kumeyaay Nation, and today the Kumeyaay people continue to maintain their political sovereignty and cultural traditions as vital members of the San Diego community. We acknowledge their tremendous contributions to our region and thank them for their stewardship. Before we begin with the technical aspects of this workshop, I do want to remind you all that you will need a Tinkercad account to participate. If you don't have an account yet, please visit this link, which is basically just tinkercad.com/join, to create a free personal account. This will allow you to follow along as well as work on your own circuits in the future. Our itinerary today is we're going to be doing some opening statements, which is what I'm doing right now. Then I will be handing off the slides to Greg so we can do an intro to Arduino, which is basically just the basics of the programming. Then we'll be moving into a challenge prompt where you will be working with a team of maybe 5 to 6 people to create your very own unique circuit. And then we'll do some closing statements and figure out what AIChE is doing in the future. So first off, AIChE Projects, if you are not aware, was created in 2015 and is a subdivision of AIChE at UCSD. We promote hands-on collaborative learning, and our 6 teams aim to solve current and pressing environmental issues. We have teams that work on anything from water treatment to the creation of sustainable energy. If you would like to learn more about our teams and our program, please be sure to visit aicheprojects.org. And without further ado, I'd like to hand it off. I'd like to introduce to you guys to Gregory Specht, who is an educational labs manager. You may know him from MAU 170, but without further ado, the floor is yours.
Thank you very much, Diana. Welcome. It sounds like a good amount of you have already taken the MA 170 class, but so if you have already taken that, there might be some refreshers to this, but I'm going to try to do it quickly so everyone's kind of at the same pace and then at the same level, and then we can get started into the fun stuff. Okay, so first off, what is Arduino and why do we care about it, right? So Arduino, in its most basic sense, is a very simple computer. You write C++ code, which if you don't know C++, it's fine. But C++ is a very basic programming language. It's meant to run on very simple machines, or one of its benefits is that it runs on very simple machines like the Arduino because it's very compact and fast. So because of that, a lot of IoT stuff runs on C++. It's a great skill to learn. A lot of employers look for C++ knowledge because it's ubiquitous across all disciplines. And having a little bit of experience through Arduino is a great opportunity to learn the language and learn simple circuitry and all that kind of stuff. But what can you do with the Arduino? So what you can do is, if you see here, these are just 3 simple projects I looked up, got some pictures of. So the first one is going to be an automated garden. And basically what this does is it waters, you have an Arduino controller set up to water the garden once a day. And then it also takes a camera and looks for weeds. And then I forget if it plucks out those weeds or if it sprays weed killer on those weeds, but it basically maintains your garden with very little work. Now, Most likely setting up this thing probably took more work than just going out there and tilling the soil with your hands. But you know, for people like me who find this interesting, it can be a lot of fun. And then we also have, this is a autonomous vehicle. It's able to sense its environment and drive around, either line follow or just avoid obstacles or those kinds of things. And then we also have like a hovercraft, and this thing is a remote controlled hovercraft, so you can, you know, use remote controls, or you can also connect it to the internet. So there's a wide range of applications it can be applied to. So one of the benefits that I really like to emphasize with why we choose Arduino, Arduino is a really easy, fast prototyping tool. So there are a lot more powerful systems out there, but Arduino, because it's so simple, it's really easy, especially for beginners, to get into it. And it's really easy because it's real easy to change things. It means that you can prototype real easily, so you can switch things up. You can reprogram it, you know, in a couple minutes, and it makes it really easy for those early design stages. Once you kind of get the design down, a lot of times you'll move it to a more permanent design system. But in the beginning, at least, it's really useful for you know, exploring different options and prototyping and all that kind of stuff. Sorry, that line's from class, but a really great thing, and this is applies to really all engineers, is that why an engineer really gets paid more than a lot of other disciplines do, is that we're problem solvers. And at the end of the day, you want to be able to solve problems. And how do we do that? Well, one of the best techniques out there is to, especially for debugging or anything, is to break down your problem to the smallest individual parts and try to attack it, figure out what's working, what's not working. And then once you really break it down to its simplest parts, it makes it a lot easier to figure out what's broken or what's not working and address that thing. As opposed to, if I were to just look at a big robot or a car or something, I say, well, my check engine light isn't working, is on, but I don't know what the cause is, right? Do I just swap out my motor? Do I change the oil? You know, so you have to figure out what the heart of the problem is in order to address it. And Arduino is a great learning tool for that. And also, you know, I've had a bunch of students who have, you know, come to me after the class that I teach and say, hey, I want to, you know, build this thing that I saw online. Can you help me do that? And I've had, you know, I've helped them make things in their spare time or in their free time or whatever. So today we're not going to be doing Arduino in the IDE. We're going to be using Tinkercad. But if you did want to go out and get an Arduino and do the hardware and software and everything, there's a Arduino, obviously it's meant for beginners. So there's a link right here, getting started. And then there's a great community around Arduino because, you know, either if you're on Stack Overflow or Reddit or the Arduino website, you know, there's a bunch of makers out there that are very excited about teaching other people how to use it. So if you have any problems, usually you can consult message boards or something like that to figure out your solution. Oh, and that's the maker community. Yeah. So Instructables has a bunch of things. The Arduino website itself has a bunch of forums and all that kind of stuff. So if you are stuck somewhere, I first recommend trying to see if there's solutions out there or if there's cool projects out there that you might want to replicate. Okay, so I'm going to be switching between this and the Tinkercad because in Tinkercad, so the basics of Arduino are, you have in the code of Arduino, anytime you start a new program, so let's say we were to go into Tinkercad and we wanted to create a new circuit, we would simply create a new circuit. And then our layout is going to look something like this. You have all your basic components over here. You can change it to all components if you want, but let's just keep it on basic for now. And then you're just simply going to drag and drop your component into your working space. I like having everything upright, so I do that. And then if you pull an Arduino in, then you should be able to click this code thing. There's the block options. I don't really like the block option. It's more meant for like elementary school children. I think it just takes a lot longer to do stuff, and it's not it's basically as complicated as text, but I think because it's visual, it's a lot more user friendly for younger people. but hopefully we can all move on to the text-based programming. And in this, there's two. It's going to start every time you start a new circuit. You're going to have these two basic things. You're going to have void setup, and void. This is just basically saying a function of setup function and a loop function. And what these are really just in your setup function. It runs once, and so everything inside of here usually should just be have it run once, and then the things that you want to continuously do over and over again are going to be inside your loop function. So that's going to be everything in here. So basically you set up your pins, you say pin mode, and that's, you can learn about that. We'll learn about that in a second, but it says, I want this to be an output pin, and then I'm going to turn this output pin high for a second and then low for a second. So I'm just basically blinking a light on and off is what this code does. And then last but not least, these squiggly brackets are used to kind of denote what is inside of your either function or well, other things, but for you guys, it will just basically be whatever's inside your function. So just make sure you have an open and closed bracket, and everything you want to run inside this function is going to be done inside these quick squiggly brackets. All right. So this is, again, if you were to run this code on hardware. So I hope you guys will be getting these slides. So if you, right, okay, so you guys will have access to it. So if you want to run it, basically there's just two buttons you can press to upload your code. You can check your code with this check mark and then upload it with the arrow. And all you have to do is you have to select which board you're using, because there's a bunch of different Arduino boards out there. So you're going to want to make sure that this is called a compiler, or your IDE is knows how to basically turn your written text code into what's called machine language. And it's going to be different based on the board that you're using. So you need to tell it what board you're using. And then you also need to say what port or how you're communicating to the Arduino. So you just need to select the port. If you're using a Mac, it's going to be called something other than COM. But if you're using a Windows, it's going to be called COM. And then usually it's COM3 is the default, but it could be COM 7, 8, 9, whatever. Yeah, and then A and B. And then how we communicate to the Arduino. So if we have the Arduino plugged into our computer or some other serial communication screen or something like that, you can communicate to it. And this is really useful for, especially if you want to like debug your Arduino. You're basically going to, inside your code, you're going to write things that say, okay, send this text string back to my computer, and then I'll be able to read that on my monitor. Now, the one big thing about serial communication is that you need to make sure that your Arduino is speaking the same language as your receiver. So, and what I mean by language, there's going to be a baud rate. And what that baud rate is just basically how fast it's talking, it's sending its zeros and ones across the wire. So for you, I would, the big takeaway here is just you want to tell at the beginning, you want to tell the Arduino how fast you should be sending your serial communication. And then when you open up your serial command or your serial plotter, or whatever it's, what's this called? Whatever. When you open this up, then you also want to make sure this drop-down menu is going to drop down to whatever baud rate you've selected. And the faster the baud rate, the quicker you send those commands or that text, and that can have a big effect on if you're pressed for time or something like that. But so sorry, this kind of talks more about it. Yeah, okay. So like I said, those commands that you're going to be using are going to be serial print and serial print ln, and then inside this bracket, you're going to put whatever text you want to send to your computer. The only difference between serial print and ln is that after it does serial print ln, it gives a return command. So return line, so that you keep going to the next line. It just basically makes it easier for you to read it. But yeah, and then you want to make sure that you use these double quotes when you're sending things. I've seen for some reason a lot of times people use the single quotes, and sometimes it works and sometimes it doesn't. Honestly, I don't know why it changes, but then I've seen it change because if you're using Mac or Windows and those kinds of things. So there's going to be slight differences. So I've always seen using the double quotes as that basically always works. So, you know, please use the double quotes when you're trying to send text over this line. And last but not least, there are more complicated ways to send text and variables. So if I had a variable, and sorry, I'll talk about that in the next slide. But if I have a variable and I want to send it over my serial line, basically I'm just going to say serial print my text and then serial print my variable and then serial print my text or whatever. And that's how you're going to send them one after the other. You can't really send them where it's like serial print text. Well, you can, but it's a little bit more complicated. So for starters, just try to just have it be multiple lines of code. And then, so you guys are going to be using these things called variables. And like in math, right, a variable can be used for to represent many different numbers or things or whatever, right? And in the C++ language, the big takeaway, if you've used like MATLAB or Python or something like that, is that the difference is that you need to declare what data type you're going to be using for a specific variable. And how that differs from MATLAB is MATLAB, basically, you can just say, you know, x equals 4, and MATLAB will figure out what data type you mean to when you say x, right? Now, there's some issues with that because then if later I say x equals a, like the letter A or something like that, it will change the data type and you have a bunch of issues with that. And if you have to define the data type, well, then you don't get those problems. So there's pluses and minuses with each way. But for this language, at least, it's just really important that you're going to define the data type. And there's a bunch of different data types. There's characters, and that's just, you know, text. And then bytes, ints, these are just basically different, well, at least these are different numbers. And basically all this is saying is just, you know, how much memory do I need to allocate to store this variable? So if I, you know, have a really small number, then I can use an integer. If I have a bigger number, I can use a long. And probably going to be outside the scope of this class, or this section, but it's good to know just to have that in the back of your mind. And then for now, we're just going to try to define all of our variables at the very beginning of our program outside of our setup or loop functions. And the reason is because if you do it within the function itself, then it can get deleted if you leave that function. So just as starters, I try to recommend everyone just has them be what's called global variables, and then they'll be able to be used all over the place. All right, so now we get to the crux of what an Arduino actually can do, right? So an Arduino is able to control pins, and those pins are either going to be read or they're going to output a value. So in the beginning of my program, I need to say I have a pin mode. So I'm going to say, you know, pin, whatever, pin 3. And I'm going to either say that's either an output or an input pin. And all you basically do is you just put in all caps output or input. And that basically tells the Arduino, okay, pin 3 is going to be an input pin. So I can only read from that pin. If you put pin 3 and then output and then you try to read from it, it's going to give a bunch of problems. It's not going to give you reliable stuff. So just keep that in mind. You need to make sure that you put pin mode, and whichever pins you're using, you need to declare those pins. And usually that goes in the setup function. It doesn't have to be, it can be really anywhere, but since it usually only needs to do it once, then it's got to go there. Or it doesn't have to go there, I'm sorry, but it usually goes there. And then if I want to then read from these pins, I can, or write to the pins, I just use the simple command digital read pin number or digital write, and I have a pin number. And then when I do digital write, I simply say true or false or 1 or 0, either one works. And basically all that's doing is saying, turn this pin to high, which is 5 volts, or low, which is 0 volts. And then digital read, when I say digital read, it's going to check this pin and then return a pin value. So like, oh, I don't have, oh no, here. So if I have a variable called button state and I set it equal to digital read, and then I have my button pin, so I want to say, is my pin high or is it low? Well, I can say digital read button pin, checks that pin, and then if it's high, it says button state equals high or 1 or true, and if it's low, then it says button state equals 0 or low or false, or yeah. So that's kind of how you're going to be controlling it, and you can do a whole lot with that very simple set of functions. And then last but not least is kind of like the logic you're going to be using. So you're going to be using what are called if statements, and you can pair these if statements with else statements. But basically what an if statement is it just says if, and then it checks a condition. It says if something has occurred, so is button state high? If that's true, then I do whatever's if within this if statement. Then if it's false, I'll go to the next if statement and I'll say else if, or I'm sorry, not the next if, the next else if statement, and say, okay, well, now the first one was false, so now let's check if this one is true. And then if this one's true, then I'll do what's in here, or if it's false, then it will go to every other else if statement, or it will go to an else statement. And the else statement will just say, no matter what, if everything before this was false, I'm going to do whatever's in here. If anything before it was true, well, then I'm not going to do what's inside here. So hopefully that, you know, it's written pretty straightforward, but the big thing is that you need to know how to ask a conditional statement or check if something is true or false. And that's just basically going to be, we have a couple different things. We have, is X equal to Y? And it's really important that you have X equal. A lot of people make the mistake that they have X equals Y. And that's basically just saying that X does equal Y. If you have equals, it says, is X equal to Y? So please don't leave that equals out. And then the other thing's pretty straightforward. Not equals, it's just saying, is this not equal to that? And then greater than, less than, greater than or equal to, or less than or equal to. And then don't ever say like X is less than 10, and then else if X is greater than 10 but less than 20. So you basically can't ever have a statement like this. You can't be checking two things at once. If you wanted to combine these, you could do an and, but that's kind of getting a little more complicated than we need to for today. So generally, anytime you have an if statement, you always just want one thing. So either is X greater than 10 or is X less than 20, but you don't want to check both of them at the same time because it usually runs into things that you don't expect it to. All right. And then since you guys are going to be using digital signals, you're going to be reading or writing them to turn lights on and off, and when you press buttons, you want to read the button press. It's important that you understand kind of what's going on with those things. So in computer language, right, you have what's digital, and that's usually going to be, the reason why we have that is because it's a lot easier to distinguish digital language as opposed to analog language, because if I am trying to read 5 volts, I have a somewhat wide range. If I want to see, is this true? It could be 5 volts, it could be 4 volts, it could be slightly above 3 volts. And if my signal is anywhere in between that value, then I know it's true, and I'm just going to say that's a 1. As opposed to if I was trying to read an analog signal and I am expecting 3 volts and it's 3.1 because of some noise in my system or something like that, because something's off by a little bit, then it might read that value incorrectly and say 3.1 instead of 3, and then you get all kinds of errors down the line. So using digital signals is a benefit because it makes things much more distinct, and computers like to be very distinct when they make decisions. And then the other thing to think about is just that when you're measuring voltage, or when it's checking its statements or checking the pins, it's going to be false between 0 and 1.5 volts. It's going to be what's called like an ambiguous state in between 1.5 and 3, and that's basically going to just depend on its previous state, because it takes some voltage to flip it from true to false or high to low or whatever. And then if you're above 3 volts to 5 volts, then it's going to be reading true. So just keep that in mind, I guess. And then if I'm going to be outputting signals, right, I'm going to be outputting those to, in today's thing, we're going to be turning lights on and off. And what lights we're going to be using are going to be LEDs. And what an LED is basically, it's a one-way valve. It lets electricity flow in one direction, but not the other. So it means that it's very important that you wire these legs properly. And if you look in here, I'm just going to pull up an LED. So if you look at this drawing of this LED, we have, and actually, oh, when you highlight it, it says it. So the slightly longer leg, or the bent leg, is going to be your anode leg, and that's going to be your positive voltage. And then your shorter leg is going to be your cathode leg, and that's going to be your ground usually, or your negative voltage. So yeah, so just keep that in mind, because sometimes people, when you're wiring things up, you accidentally mix them up, and you apply your ground here and your positive voltage here, and then your light won't turn on, and you don't know why. So it's just important that you see that. I'm not going to get into the math behind it, but just know that an LED doesn't work the same way as a resistor. A resistor always resists current flow. An LED is going to just have a constant voltage drop across it, as opposed to a resistor will have a variable voltage drop across it, depending on the voltage being applied to it. So, so yeah, so that's kind of how LEDs work. And now I just kind of want to quickly run you through Tinkercad and why it's useful. So in Tinkercad, right, we're going to have our basic components, and later you guys are going to be able to explore all the components, and I highly recommend that. But for now, let's just look at the basics. There's a bunch of different like sensors out there. We have buttons and all this kind of stuff. Like I said, I always like to rotate my things so that everything's kind of this way. But in order to interact with these things, I need to start my simulation while the simulation isn't running. This is while I'm setting or building up my circuit, so you can't really do anything like turn a light on or anything like that until you hit the start simulation button. But I can show you a real quick thing. If I wanted to do something like this, 5 volts to here, and then this goes to here, and then I can start my simulation, and then when I hit the button, it turns the light on, right? So now the reason why this turned super bright, or it gave me that thing, is because you're supposed to have I just realized that you're supposed to have a resistor to resist the current, because too much current is going to be flowing through here. But just for demonstration purposes, let's do that again. And now it glows. And depending on how big this resistor is, it's going to change how bright that light will be. So the smaller the resistor, the smaller or the brighter that light will be, basically. So another thing, sorry, real quick, is that you can also click on any of your things, and I can just change its properties usually. So right here, right, I just clicked on it and I was able to change the resistance of this resistor, or here I can change the color of my LED if I wanted to do that. And then a lot of times, in order to make things more easily to follow, I'll use wires as certain colors. A lot of times red is high voltage, black is ground, blue might be like a intermediary wire or something like that. But it's not necessary to wire it with colors, but it's just very helpful for debugging and all those kinds of things. Okay. Now I want you guys to be able to have plenty of time to mess around with this stuff. So I hope I stayed within my time constraints, but are there any questions with Tinkercad before we kind of let you get started? Oh, actually, here, I'll just show you. So you guys are going to be, we've already built a circuit for you, and it's going to be called the AIChE project. When you open it up if you follow this URL, when you open that up, it should bring you something that looks very similar to this, except it will say copy and save, I believe, because I've made the circuit already. And then this is the circuit, and basically what this does is we have all this code, and I tried to put all these comments in here to try to tell you what's going on with everything. But basically what's happening is you have it's going to randomly turn on a light, and when it randomly turns on that light, you need to press that button, and it gives you a point. When it gives you the point, then it will move on to the next light. Here, let's just play. So I gotta, so it all blinked, so that means I lost. So I gotta press that button. I gotta press that. And then as the game goes on, oh, dang it. As the game goes on, it will get faster and faster each time. So it's a really simple, little game. Not too much fun, but it gives you a little practice and lets you see how things go, and then it gives you your score. So if you play this, you'll see that the more buttons you press, the higher your score. So each time you press one of the buttons, it keeps track and adds it up. Yeah, so, okay, cool. So are there any questions? I didn't read the chat, but are there any? Yeah, exactly. Sorry, so Jaden said that he one time wired the LED directly to 5 volts and blew out the LED as expected. So, these things are low voltage, but they can get really hot for very small components. So just be careful if you guys ever do this in person, because, you could possibly light a LED on fire, and we would never want to see that, right? In uncontrolled environment. Okay, so let's get started then, right? Anything else? Okay, cool.
Okay, I'm just going to present this slide really, really quickly. We're going to be moving into our challenge prompt portion of this workshop. I hope I can share the correct screen. But basically, in groups of 5 to 7, we're going to be sending you the completed circuit. There will be a breakout room leader or 2 in your room who will be sharing the circuit for the entire group. As a group, you guys will be working to possibly tinker, if you see what I did there with that pun, possibly tinker with the circuit, make a few changes with what you've learned today. We'll reconvene in approximately 30 minutes. We'll play it by ear to see how you guys are doing. And you guys can show off the design that your team comes up with. If you need any ideas, some things that I just came up with on the fly was possibly adding another LED light system to the circuit, add a little bit extra difficulty to what Greg has given us, or you can create a pattern rather than just having some kind of a random one. I will add to note that it doesn't have to be completely finished as long as you can have something to share at the end of this. Words are phenomenal, and you can use them to share what your team was trying to do. There on the screen is a QR code that will take you to the circuit that you can copy if you'd like to follow along with the rest of your team, as well as the tiny URL is also on the screen. So does anyone have any last minute questions? I believe, Greg, would you be good for floating around the different breakout rooms? Yeah, okay. That's good. I got 10 seconds if anybody wants to ask any extra questions, or let me know that you're going to ask a question so I can wait for you. Okay, I think we are all good to start. Let me see. I'm going to open up the rooms. You should be randomly assigned, but please let me know if you are not. Just to backtrack and summarize, we just went into breakout rooms to spend a little bit of time to tinker with the completed circuit that was given to us by Greg. And we're gonna take a little bit of time to go over these circuits that you guys made. I saw some very fantastic ones in the process of creation. So we'll just go by breakout rooms. We have first up is room 1, I believe, with Victor and Sean. Would you guys like to share really quickly what you guys did?
I can share.
Oh, let me make sure that you can share. I believe you can.
Yeah.
Yeah.
Okay. Can you see my screen?
Yep.
Yes.
Cool. So we kind of just added 2 more bulbs to the original circuit so that there's like more buttons to push. And there wasn't enough space for the 5th one, so we had to add another breadboard and put it in series. So yeah, but it looks like it works. So I think if I just do this.
It was quite interesting. I was in this room to watch this being created, and we didn't know how to put the breadboards together, and we were just like, this wire goes here.
Yeah, we were surprised it worked.
It worked. So
yeah, but it seems like it works. So yeah, it came out good.
Cool.
alrighty, thank you so much for sharing, Victor.
Did you have any, were there any, yeah, the breadboard was a struggle. Was there any other epiphanies or anything like that?
I don't really think so. It's kind of just like trial and error, kind of figuring out what some of the code was doing and then copying and pasting it.
Okay. Cool.
Okay, so next up we'll have room 2. I believe that was Harleen's room.
Yeah, let me share my screen. So we added a temperature sensor, and when it gets really cold, the blue light turns on, and then warm the yellow one, and then when it's hot, the red one.
Can I ask what numbers the serial monitor is outputting?
Oh, that's the temperature.
Okay, got you. Okay, thank you so much for sharing. I see some cheers and claps from our participants. Next up we have
Harleen,
room. Oh yes.
Sorry, Harleen, were there any surprises or interesting things that you found out about this?
To be honest, I had no clue how Arduino works when I started it, so I feel much more confident now.
Cool. That's great.
Okay, next up we have room 3.
I can share it. So I didn't do much. We just added another set of LED lights because I was new to Arduino. And then we noticed a few strange things. That is, the blue light always turns on the first. And so it means the random number, as Jaden suggested, always use the same seed. So the blue light always turns on the first. And then I guess just another thing I noticed is that every time I play the game, let's see, the score is always 0, but it just turns out you have to hold to the button a long time so that it's considered a success. Yeah, that's just it.
Yeah. Were there any attempts at making it so that you just had to click the button, or? was it just discovered and then no?
I don't know how to do that actually. So
Okay.
Okay, next up we have room 4.
I can share for that one. Give me 1 second. So we adjusted it so that when the light lights up, a sound also plays with it. The sound is a little bit jarring, so I just want to warn, just want to put a warning out. I'm gonna play it now. Yes, that's what we did.
Cool. Really cool. There's you can actually have a tone. So if you wanted to play like musical notes and stuff like that, you can, I don't know if you guys saw that, but if you want to explore that.
Yeah, we were trying to get it to play Happy Birthday If You Lost.
Oh, really?
Yeah, but we couldn't get it to work. We actually we just wrote it out note by note, but it just didn't work.
Okay.
Yeah.
I think there's an actual way to like get the song in there, but we weren't sure, so we just got the frequency of the notes and just put them in there line by line. But yeah, it was pretty fun.
Cool.
Alrighty, those are some great looking circuits. I'm glad you guys got to, put your own spin on what you were given. I'm gonna share my screen really quickly. I believe that is the end of our material today. Thank you to Greg for, leading this workshop and giving us some insight to Arduino. Before we end today, just for some closing statements, I'm going to talk a little bit about AIChE's upcoming events. Let's go through this really quickly. I believe tomorrow at 6 p.m. we have an AIChE UC Inter-Chapter Social. It's a little bit of a mouthful. I almost didn't make that. But at 6 p.m. tomorrow, we will be hosted by AIChE at UCLA, where you can play some games, meet some fellow chemical engineers across California. There is no RSVP needed, and the Zoom link is on the screen. I will also be posting things in the chat on our final slide, just so you guys have that for your leisure. I'm using that word a lot today. I don't know what the filler word for that is, but yes, that will be happening tomorrow at 6 p.m. We will also be having a TapX fundraiser on Thursday, May 27th, which is next Thursday, basically all day starting at 10:30 a.m. You can come and support AIChE by joining our Boba Run, and you can also get a 5% discount for any purchases that you make on this day. Be sure to visit our Facebook page for the flyer, or you can also reach out to anyone on leadership for getting the flyer. We will also be having an end of the year bonfire on the same day at 6:30 p.m. This is a great place to be able to take a break from stressing about your midterms or finals and things like that. And we'll be playing Jackbox as well as a Wikipedia game tournament. If you're interested, the RSVP link is also on the screen, and I will be pasting that in the chat as well. Now, we can't talk about upcoming AIChE events without talking about NICHE. So NICHE is the Nano and Chemical Engineering Day. It will be happening midway through fall quarter of 2021, and it's a 2-part event designed specifically for nano and chemical engineers, as most career fairs often focus on other majors. We will be having a pitching competition with cash prizes. If you're interested, you should join. There will also be a career fair with industries and recruiters that want to hire you. And we are also looking into bringing in several grad school recruiters so you can learn more about their programs. Watch out for events from AIChE in the beginning of fall quarter that will help with career fair preparedness, such as like a resume workshop, elevator pitches, things like that. And we just wanted to welcome you and have you join us to find your niche. And with that being said, thank you to for joining us today. Special thank you to Gregory Specht for leading this workshop. Thank you for spending your Friday afternoon with us to learn more about Arduino. I hope you all have a wonderful weekend. The recording of this workshop will be available on YouTube as well as our website, AIChEprojects.org, within the next few days as soon as the recording renders. And if you've missed it, please be sure to sign in. The QR code is on the screen for you. And I hope you guys all have a fantastic weekend. I won't spend any more of your time here. And I hope you guys all have a great week 8, week 9. Yes.
Real quick, if anyone has any questions, because I only jumped to one group and I kind of ignored everyone else, I apologize. So if anyone had any questions about projects they were working on or were wanted to be working on, I'd be more than happy to stay around for a couple of minutes to answer those.